All right. So in today's webinar, we will look at the benefits of leveraging Spring Boot and test containers in software development. In this session, we'll explore the importance of testing and the advantages of Spring Boot test containers brings to your development process. So let's get started. As we all know, testing plays a vital role in software development as it ensures the quality, reliability, and functionality of your applications. Testing provides several key benefits in software development. It enables early bug detection, improves code quality, boosts confidence in deployments, and reduces risks and costs. By prioritizing testing as an integral part of your development process, you set the foundation for building robust and successful applications. Now, let's dive deeper into a specific and fairly traditional type of testing, which is unit testing. Unit testing is critical component of the testing process, focusing on testing individual units or components of your code in isolation. These tests provide numerous benefits that contribute to the overall success of your software development efforts. Let's take a closer look at the benefits. One of the primary benefits of unit tests is ensuring the correct functioning of individual units of code. By writing tests that specifically target each component, you can verify that it behaves as intended. This helps catch any errors or unexpected behavior early on, ensuring the reliability and the accuracy of your code. Unit tests provide a fast feedback loop during development. By running tests on a specific unit of code, you receive immediate feedback on the correctness of those units. This rapid feedback allows developers to quickly identify and fix issues, reducing the likelihood of bugs propagating to other parts of the system. Unit tests facilitate easier debugging and troubleshooting. When a unit test fails, it helps pinpoint the exact location of the problem, making it easier to identify the root cause. With a well-designed suite of unit tests, developers can isolate issues more effectively, saving the time and effort in the debugging process. Unit tests support refactoring and code maintenance efforts. When refactoring code, unit test acts as a safety net, providing in confidence the desired functionality is preserved after modifications. Additionally, as your code base evolves, unit tests act as documentation, helping maintain code quality and preventing regressions. Unit tests is crucial for ensuring the reliability and the correctness of our code. However, it's not without its challenges. We'll examine some of the common obstacles encountered during unit testing and explore effective solutions. In-memory databases such as H2 or HSQLDB are commonly used to simulate database interactions during unit tests. However, these databases often have limited features and may not accurately reflect the behavior of the actual database. This can lead to inconsistencies and unreliable tests. To isolate dependencies, developers often create mock objects or stubs that mimic the behavior of external dependencies. While this approach provides isolation, it can be time consuming to set up and maintain. Additionally, it may not accurately replicate the behavior of the real dependencies, potentially leading to flawed test results. Test doubles, such as fake objects or dummies, are used to replace complex dependencies during unit tests. These simplified implementations help in isolating units of code. However, they don't always replicate the exact behavior of the real dependencies, introducing the risk of missing important edge cases or interactions. In unit testing, many developers often manually configure test-specific settings such as DB connections, strings, or API endpoints. This manual setup can lead to inconsistencies and completely complex issues across different environments, making tests harder to maintain and execute reliably. As applications and their dependencies evolve over time, maintaining and updating test configurations become a significant overhead. Keeping test configurations in sync with the changes in the application require constant effort and attention, leading to potential errors and inefficiencies. So, as you can see, traditional unit testing approaches often encounter various challenges. Now we are going to take it a step further. Spring Boot and test containers provide a valuable tool set to enhance your testing capabilities. By integrating Docker containers with Spring Boot applications, this framework offers a range of benefits for integration and end-to-end testing. Let's take a closer look. So, Spring Boot and test containers simplifies the management of dependencies and external services required for testing. By leveraging Docker containers, you can encapsulate and configure these dependencies in an isolated and reproducible manner. This eliminates the need for manual setup and ensures consistency across different testing environments. Setting up and tearing down Docker containers can be a complex task, but Spring Boot and test containers streamlines this process. With a few lines of codes, you can define and configure your containers, allowing for seamless integration with our testing workflow. This easy setup and teardown mechanism significantly reduces the effort required for container management. Spring Boot test containers seamlessly integrates with Spring Boot and JUnit, making it an ideal choice for testing your Spring Boot applications. You can use familiar annotations and configurations from the Spring Boot ecosystem to define your tests. Leverage the power of test containers to enhance your testing capabilities. So now let's dive into a small demo where we can discuss and see all these benefits which we discussed just now. Let me share the screen. Let me switch over to the code. Just a second. Right. Okay. Let's see. So this is a very basic Spring Boot application. Of course, anyone who is familiar with Spring would know that you can go into start.spring.io and you can add in the dependencies. So the basic dependencies which I have added, let me walk you through them as well. All right, cool. So here we have, we obviously need Postgres, which is the database which we are trying to execute our tests on. And these are the main dependencies we need. So we need the test containers provided in the Spring Boot ecosystem, along with the test containers for the Postgres, as well as the interesting thing is in today's demo, what I'll do is I'll be running these tests use on Postgres as well as MySQL. So you will see that we have test containers for Postgres as well as MySQL. And of course, we need the connector dependency as well. So this is the basic dependencies we need. So I'll walk you through the code. It's very simple and a rudimentary one. So just we are looking at a movie repository where we save movies to the database, right? So this is just a basic movie entity where we have an ID, name, and a rating and a repository. So here, for the demo purposes, what we do is we do the top rated movies. So let's assume that we all know that there are a lot of movie rating sites. So IMDb, maybe let's consider that. So any movie which has the rating above 7 will be considered as a top rated movie, and we'll be retrieving it from the database, right? So this is it. This is just like I just wanted to like there's no major rest endpoints or anything. This is just to show you that okay, how we can test a certain method. So this is basically unit tests where we can easily configure and test it on using the test containers, right? So the demo application, it basically will start it up. So let's move a bit into the test itself, right? So here you can see that there are many ways where we can integrate the test containers and get it up and running. So one way is when it comes for the setting up the unit test, you can define it as a container like this, right? I have commented it out. I'll explain the reason in a bit, right? So the first way is you can have a define a container like this, and we all know that when we add this dynamic property source annotation, it will be given the highest priority. So even if you have defined any application properties here under the resources, dynamic property source will get the higher priority, and it will basically pick up these values, right? So here what is done is we define a Postgres test container, and here, the importance is we can pass on the latest image we want, right? So we can go with Postgres 12, or if needed, we can change this into latest, and then it'll pull out the latest container when you run the tests. So this is one way, right? But what I have done is I have taken it a step further, where I'll be running the basic test. So the basic test on MySQL as well as Postgres, right? So here what I have done is I have utilized the profile setting of Spring Boot application. So for Postgres, I'll walk you through how it is being set up. So here we are using a very basic JPA test, and we are using the Postgres configuration. In Postgres, this is where the simplicity comes in, right? Within just like 2 lines of code, you can set up the database. You don't have to worry about the credentials. You don't have to. So if you look at the application properties itself, if you're running the application locally, you need to set up the details, set up the host and everything. But in test containers, the beauty of it is it's just like 2 lines here. You will see, okay, the URL will be JDBC and TC for test containers and Postgres 12. So this is the Docker image which we are using. And after these 3 slashes, you can define the DB name if you want to, so that your tests will run on this DB instance, right? So this is how Postgres is configured. Let's move on to MySQL also. So here you will see that there is a bit of more configuration involved, right? The main reason is here we again the data source URL is pretty much the same, right? So you can see we define it as JDBC test containers, and then we can go with the Docker image, and we are using the same DB name. Apart from that, since we are using Hibernate, we for MySQL we need to specifically say what's the dialect as well as the identifiers. So this is the configuration for MySQL, right? So now let's get down and dirty, and let's run the test. So first, let's run it on Postgres, and I'll walk you through how the whole setup will run. So it's just a basic Maven clean test. All right, so here you will be able to see, okay, the test's passed. So if you look at the test, what we are going to do is, so here we will see that, okay, the we will save the details here, the movies, and then we will be rating them. And whatever the movies which have the rating more than the 7, they will be retrieved, right? So now let's go through on how it will be how the tests are run. So here you will see that, okay, initially when you are spinning up the details, so here you will see that the test containers, there's this test container called rook. So this acts like the garbage collector, right? So what happens is this is the main container which is responsible for spinning up the images and tearing it down. So initially they will say, okay, it will start up. And so the advantage of this is, uh, let's say if one of your tests fail, what will happen to the Docker containers which were spin up, right? So that part, so tearing down the resources and deallocating, that is handled by this root container. So it will initially spin up, and then you will see that for Postgres, uh, test containers utility, okay. Now you will see that the Docker server checking the system. All right. So here you will see test containers, Postgres 12.9, creating a container image, then pulling the details up. And once it's started, it will insert the details and assure that our tests are running well, right? So this is on, this test was run on Postgres. Now let's go and see on how we can change it to run it on MySQL, right? So it's very simple. We change the profile for MySQL and let's run it and see. So there's a small delay while the container is spinning up and they're looking for a health check. And once it's up and running, all right. So here you will see that, okay, uh, again, it's the same, right? So we have the Ruik container coming in. He's like the janitor and the person who is taking care of the whole details. So as we said here, Ruik started will monitor and terminate test containers on JVM exit. So whenever the tests are run and done, this will take care of the deallocation of resources and shutting down, right? So here you will see that now the details are running on MySQL. So here you will see that, okay, the tests are run again and the inserts are working and the tests have been run. So this is like the basic walk over where we see the real like benefits, right? So as I told you earlier, we don't have to like go deep into setting up or having local DBs up and running. Or so one thing is, now if we are to use Spring Boot H2 database, there might be cases where the data types would act different, right? So if we are to run our tests on, say, a different one, maybe uh, Postgres or MySQL, and if we are to run the testing on H2, there might be discrepancies. So this setup basically eliminates that whole set of complexities, and it will add more value. So this is a very basic demo. So as and if you need the source code and access, do drop us a mail. We'll share the email details at the end of the webinar. You will get it, and we'll be able to share the source code as well. And this is just the start of it, right? So this is not limited to just DB database test containers. There's a huge set of containers. If you go into testcontainers.com, you will be able to see what are the available ones. And the beauty of it is Spring actually supports all these containers out of the box. So it's just a matter of like having a set of this, defining a container like this, and using it in your unit tests. So let me switch back to the presentation. Right, we were on. Yeah, we were on slide 5. We discussed how simplified management of dependencies. So if you are building a Spring project, as we discussed, go into start.spring.io, just add in the test containers and whatever the DB instances you need, and you can get it out of the box. So easy setup and teardown of Docker containers. It's already handled by the RIC test container, so we don't have to worry about like having local DB set up, having local Kafka and messaging gateway set up. The ROIC service, as long as we configure it correctly, it will do the setting up as well as the tearing down, and seamless integration with Spring Boot and JUnit. As I said, if you go into just it's just a matter of like creating a Spring Boot project with the dependencies, and you can just start off and go on with the unit testing using test containers, right? So now, let's see what are the benefits it offers when it comes for using test containers along with Spring Boot. So, Spring Boot and test containers offer several development benefits that impact the way we build and deliver software. So, let's discuss some of the key impacts this framework can give on the development process. With Spring Boot test containers, developers can set up and tear down containers seamlessly, allowing for faster feedback during the testing phase. The framework automates the process of provisioning and configuring dependencies, eliminating the need for manual setup. This accelerates the feedback loop, enabling developers to quickly identify and address issues, improving overall development efficiency. Spring Boot test containers provides a standardized approach to testing dependencies across different environments. This promotes consistency and ensures that all developers are working with the same testing environment. By reducing environment-related issues, the framework facilitates better collaboration among team members, leading to smoother development workflows and enhanced productivity. By streamlining the testing process and improving test coverage, Spring Boot test containers contributes to increased development velocity. Developers spend less time on manual setup and configuration, allowing them to focus more on writing high quality code. With faster feedback loops and improved collaboration, development teams can deliver software more efficiently, meeting project timelines and customer expectations. So let's discuss a bit more on the benefits for project management as well. Spring Boot and test containers offer a wide range of benefits that have a positive impact on projects built with Spring Boot. Let's explore some of the overall benefits this framework provides and how it can enhance your project success. By integrating Docker containers, we can precisely replicate the required dependencies such as DBs, external services, ensuring consistent and reproducible tests. This reliability leads to more accurate test results and increased confidence in applications functionality. The streamlined setup and teardown processing of Spring Boot test containers significantly reduce the time required for configuring test environments. Developers can quickly provision the necessary dependencies, eliminating manual setup efforts. This faster time to market enables you to deliver features and updates more efficiently, gaining a competitive edge in the market. Spring Boot test container simplifies dependency management and eliminates the complexities associated with setting up external services for testing. This allows developers to focus more on writing high quality code and designing robust application logic. By reducing the time spent on manual configuration, developers can increase their productivity and focus on core development tasks. With Spring Boot test containers, you can ensure consistent testing environment across different developer machines and testing environments. The framework provides a standardized approach to containerized testing, ensuring that everyone works with the same configurations. This consistency reduces the chance of environment related issues and improves the collaboration among team members. By leveraging Spring Boot test containers for comprehensive testing, you gain increased confidence in your deployments. The framework allows you to thoroughly test the integration points and interaction with external systems, reducing the risk of failures in production. This confidence leads to smoother deployments and a more reliable end user experience. So these are the many benefits we have when it comes to improving the development productivity as well as the quality of a code when we use Spring Boot and test containers in our day-to-day lives. So this kind of brings the webinar to an end. So thank you very much for participating. So now we'll open the floor for any questions. So if you have any questions, now is the time. If we don't have any questions, we can conclude it. Yeah. Any clarifications? And as I said earlier, I will be able to share this code example when it with y'all. So just do drop us an email for the email mentioned in this presentation, and we'll make sure that you'll get the basic code set up and the presentation as well. All right. So, yeah, looks like we don't have any questions at the moment. But then again, as I said, if even if you have any questions, do drop an email for info@allianttechnologies.com, and we'll be very happy to clarify as well as share the resources for this webinar. And thanks a lot, everyone. So, yeah, thank you very much for joining. And I hope that you learned something new. And what I would like to say is there's a plethora of options where we can do wonders using test containers. So this demo was a very short and a very basic one. So hopefully, if we are to get a positive response, we will be able to go a bit more detail and a bit more technical, maybe with another webinar. So again, try out the options, and if you have any questions, do drop us, and we'll be happy to help. Thank you, everyone.
Thank you, Harsha.
Thank you very much.
Thank you, Harsha.